So I've just shown you graphically that if you have a single equation with two variables, then there are an infinite number of points along that line which make that equation true. But if you have two variables and two equations, which is what we're going to be talking about here, two variables and two equations, so then there is a single solution. I'm going to show you how to find that solution. And so first of all we have to do is isolate x in one equation. Then you replace that x value in the second equation and solve for y. And thirdly, you replace y back in the first equation and solve for x. And then lastly, you check by substituting those numbers back in both equations and making sure everything's all right. Okay, so let's return to our two equations from before. So we've got y equals 2x plus 1 and also y equals minus 1x plus 2. So this is the standard form that our equations normally come in. So what do I need to do first? I need to isolate x in one of the equations. So I'm going to do that in this one on the right. Why not? So I'm going to use my rules for manipulating equations. So y minus 2 is equal to minus 1x. I've moved this over to the other side. And then I need to divide this by minus 1. So that means that minus y plus 2 is equal to x. Awesome. So now I can substitute this whole thing. So wherever I see an x, I can substitute that by minus y plus 2. So I'm going to do that over here. So y equals 2 times minus y plus 2 plus 1. And so now we can just proceed. So y equals minus 2 plus 4 plus 1. So, sorry, minus 2y. So y plus 2y is equal to 4 plus 1. So 3y is equal to 5 and y is equal to 5 over 3. So we need to divide both sides by 3 to get y on its own. Okay, so I've isolated x in one equation, replaced x in the second equation, I've solved for y. So now I need to go back into this first equation and replace y by the number I found. Okay, so here we've got minus y plus 2 is equal to x. So that's minus 5 thirds plus 2 is equal to x. So that's this business. So then we could say that minus 5 thirds plus 6 thirds is equal to x. So that means x is equal to 1/3. So there you have our solutions, and that's rough, my bad drawing aside, that's about what we saw with the intersection of the two graphs. Right, so now I'm just going to check that my answers are correct. So here for the first one, we've got y equals 2x plus 1. So then if I substitute the values, that gives us 5 over 3 equals 2 times 1/3 plus 1. So that gives us 5 thirds equals to 2 thirds plus 3 thirds, which works. So 5 thirds is equal to 5 thirds. That's the first equation. And then for this one on the right, y is equal to minus 1x plus 2. So that gives us 5 thirds equals to minus 1 times 1 third plus 2. So 5 thirds is equal to minus 3 thirds plus 6. Sorry, minus 1 third plus 6 thirds, which again adds up. Alright, so those are the rules for dealing with simultaneous equations and a worked example.